presenter display. Yeah. Okay. Can everybody see my screen? It should say the title of the topic, dive into Android build system.
Yes.
Okay, awesome, awesome. Um, Welcome and thank you for joining in my talk on dive into Android build system. When I was thinking about presenting on this topic and started to put down the presentation together, I realized there is so much I want to discuss and talk about, and also wanted to like start with some basics. So, you are amazing to this talk because this is, I think, the fundamental in a way. And same, Mauricio, if I spell it correct. So this presentation starts with the foundation, and that is what I was discussing with Deepa earlier. Like, let's do more. Like let's dive into this presentation, and then let's do deeper dives coming going forward. A quick introduction about me. I am Meha Garg. I am an Android developer at Tinder for over 5 years now. I'm also a member of Women's Developer Academy. Highly recommended if they open enrollment again. And that is also how I met Deepa. Also a part of Women Tech Makers. You can connect with me on Twitter, LinkedIn. And yeah, with that, let's take an overview of the presentation structure. The agenda is mainly I'll discuss on what is a build system in general, why do we need a build system, and then broadly divided into three sections. We will touch on important concepts of Gradle, the API, and the foundations around it. Secondly, we will also talk about Gradle and Android Studio and what to expect or how things work in a bundle. And finally, I want to touch a lot on Android Gradle plugin, but with the time constraint, I realize I can only do a telescopic view on it. So this is my presentation in a nutshell, which I think it is my journey that I cramped in like in 1 hour of talk. So with that, let me start with how I feel when I started learning Gradle, or I had to fix some issues with the Gradle. I think I had like kind of hate relationship in the earlier times because coming from Android Java background, to work with bills, right? Like it's so seamless that you don't expect to things go wrong very much. And if they go wrong, you quickly Stack Overflow, find some things, put them in. If it doesn't work, do more in. Very much like my joke on the slide. And then I realized like it's not scalable, it won't work. At some point I have to deep dive. And I think also the Android community in general blamed Gradle for everything. My builds are slow, publishing a library is confusing, I'm running into ProGuard issues, like there are some data binding issues, whatnot. And I would say Gradle is not a source of all evil. It's not true. And there are so many great talks on Gradle optimizations, performance, but unless you look around the documentation, it's really hard to understand how everything is needed or wired together. Another thing that also scared me was was Groovy at a time. Um, Please don't get me wrong. I am not trying to judge Groovy as a language. I never used Groovy for a real project. But using it as a Java Kotlin developer without any hints of the IDE is absolutely terrifying. Until Kotlin came along, like Kotlin became the first class language on Android, and Gradle quickly adopted Kotlin. The source code started coming into two different languages, which was amazing because now I could compare Groovy and Kotlin side by side. And it also helped me overcome my inhibitions on Groovy as a language. And I started seeing so much patterns between Java and Kotlin together. The only difference for me initially was just the build.gradle files are now called build.gradle.kts files. But other than that, it was perfect. Also, I think when Kotlin was adopted, it also bring some of the best of the Kotlin language functionality in a way that Kotlin is a statically typed language and Groovy is a dynamically typed language. So it had some like advantages on the runtime, like the types are pre-configured, predefined, and tested before you execute. So that was good. Another advantage was also it bring a lot of conveniences of the IDE in terms of auto completions came in, source code navigation was easy, and of course it's easy to work in a single language throughout. So why do you need a build system? Or before we dive in, let's see what is a build system, right? When so when you say let's say you have a Kotlin file, you worked on it. There is a class file, there is a Kotlin class file, and you want to generate a bytecode. Kotlin compiler will do it for you. In fact, our IDE Android Studio also does that out of the box, where it converts your class KT file into a bytecode. But what more is required then is when you want to convert into a binary so it can run on the Dalvik VM virtual machine, the class is then further translated to runtime format. And each one of the tasks needs to be executed in a tandem, or in an order. And that's where this is like one class. Imagine we have thousands of classes with multi-module projects. It is not gonna scale if you do it everything by hand or manually. Hence, what is the powerful build system? It a program that can orchestrate different execution of different tasks across a compilation. I know it sounds too much jargony, but just imagine it's an orchestra. It can orchestrate different tasks and it can compile. So you start with some input, it goes through some box and it gives an output. And under the hood, it does everything, whatever the magic you think of. It is more like a software factory that can run tests, can write code from multiple sources, generate documentation, create multiple build variants, publish our applications, manage our dependencies. And we continuously change, build, and release our app. With that, let's also quickly look at a timeline because believe it or not, you will come across these words more often. What is an ant? What is Maven? What is Gradle? How they are interconnected. So the timeline really helped me understand the connections between them. Ant and Maven are also both build system, and Maven is extensively used for dependency management. And Gradle came along after Ant and Maven, so it kind of grew out of it. So it had the best of both. I think also in the earlier times when Android projects were built, as an IDE and was the build tool. I think it was like more way back in 2008 to 13ish time frame. Um, we'll next see what makes Gradle such a powerful build system. Um, So think of Gradle as one shop stop. Gradle is an open source project and was built using the best features of Ent and Maven. It is platform agnostic and can be used to build any kind of project, be it written on C, C++, Swift, Java, Scala. It also supports Groovy and Kotlin as a build language. It has features such as caching, incremental builds, IDE support, and also supports multiple projects like on multi-platform projects and more. Hence, Gradle actually became a software factory for build system. Um, Interestingly, it was introduced in 2013 when Android Studio became the main IDE for building Android projects. That's when in Google I/O, Gradle was announced as a preferred build system. And since then, it is very impressive that the Gradle team and the community have come forward and iterated so fast in terms of building new features, able to handle many complexities that came with the Android um, builds, and continuously improving on performance, caching, incremental builds, cartoonizing the scripts, tooling, and much more. It's a really great talk. If you have time, highly recommend to watch it. And with that, let's dive into Gradle Foundation basics. Um, in this presentation, I want to touch upon three main concepts of the Gradle. The first will be Gradle APIs, which lay the foundation, and you will use them in order to internally work with Gradle debugging or understanding how the plugin works. The second is the Gradle lifecycle. It is very important because you it is everything that happens from the build start phase to the build finish state. And Gradle goes through three distinct phases. So I think it is important to know that as a concept. And finally, I want to touch upon a little how Gradle optimizes or works on the incremental builds kind of thing using task outcomes. I think that is the foundation for the next presentation because it is a topic in itself, but I want to touch. So So, as we discussed, let's start with Gradle API. Gradle models its build using project, plugin, and task. These three APIs are the core to the Gradle development. The terms API, models, and building blocks can be used interchangeably. So, with that, look at plugin first. What is a plugin? Plugins are predefined set of tasks and conventions that can be applied to a project. It is used to modularize and reuse project configuration, which gives additional functionality. To name a few, we all have heard of Android Gradle plugin, Java plugin, Kotlin plugin, etc. So just understand like plugin is some concept which is applied to the project, the Android build in general or any build in general. The second is project. This is the main interface or the main API used to interact with Gradle from the build file, from the script file. And the way the Gradle works, it always starts with build.gradle file. So just correlate project and build.gradle together. They always work. There is a one-to-one relationship between a project and a build.gradle. Another interesting concept is plugins are applied to the project. So in Gradle or in Gradle builds, everything revolves around the project. Like projects are the first class citizen. You apply plugins to the project. You do this to the project or that to the project. The next is task. It's the smallest unit of work. That, that project consists of. So consider a collection of tasks which are contained by the project. So task is nothing but it takes an input and produces a specific output. And then all the tasks are kind of working together in order to make a project build successful. Um, so, for example, in our app in Tinder, we have over 500 modules, and each module is considered a project. So, imagine there are 500 projects or more, and it has like more than 11,000 tasks. So, project has tasks, and plugins additionally add more tasks to the project. And the next is action, like what a task consists of, right? Finally, task will also have something that it executes. So the word execute goes with it, that action, and the action is as a task in a say. So action is the smallest unit of work. In a task, it can have multiple actions by calling do first, do last. We'll see in the demo. So after that, we have a live demo where we'll actually go into Android Studio and make some changes task or write our own, you know, small task. Another important concept with just the APIs is called a convention. Conventions are great for multi-module project where we want to share dependencies, task configuration, and other settings between the multiple modules. It is a way for project to know where and how shared dependencies are configured. In turn, Gradle will try to optimize them. So project apply plugin and plugin set the conventions, and finally they are all routed to the project. So, like a project consists of task has actions, and you have plugin and conventions which are additionally applied to the project, which add further tasks to the projects. And then we will see how these tasks are coordinated or what is under the hood for that. So what is a task? So every Gradle build is made up of one or more projects, and every project is made up of one or more tasks. And when the project is configured using any number of plugins or conventions or any number of tasks, it gets flattened and then evaluated. The tasks are evaluated and modeled into a directed graphs, which in turn determines the order of the execution of this task. So I know it's getting too heavy on the theory. Let's look at Java plugin. It's a very simple plugin example. So I took it. I know it's not Android related, but let's look how the Java plugin works. Um, let's say you requested a command called build task, which in turn depends on assemble, in turns depend on jar, and it depends on classes, and further not. But this is how. So like if you want a build, a jar file or some kind of Java binary, you have to go backwards. So the leaf node task will start getting executed, and then they will come up in a way getting like executed further. So the input of the first one becomes the output for the other, and like that. So that is all about the APIs I want to talk. The next is task outcomes. What are task outcomes? This is second important concept when it comes to Gradle, and very much used for performance improvements. So when Gradle executes a task takes some input and generate an output. A lot of times, if inputs haven't changed, the outputs don't change, right? Like not a lot of times, always. If there are no changes in the inputs, the outputs stay the same. It's a function, right? So input in the context of the Gradle is any source files, classes, script files, anything. When task is labeled as executed, meaning its input has changed, its class files have changed, and Gradle will need to run them again. This is the worst case scenario from the performance standpoint. When task is labeled as from cache, let's say you have switched branches and some of the task inputs haven't changed, it will try to reuse those outputs from previous execution. And tasks are up to date, meaning there is no change in the input. Hence, output from the Gradle is intact. It is great from incremental builds. One thing you can do is execute the Gradle command twice and monitor the time it takes to execute. If it takes time, the second time equally as the first time when you execute it, then there is something wrong. But the Gradle caches all those by default under the hood. Um, and next, let's dive into the next and final concept on Gradle, which is lifecycle. So there are three phases of the life cycle: initialization phase, configuration phase, and execution phase. In initialization phase, it looks at different projects and analyzes them. So for example, from our app perspective, you can have one or two projects, and it can scale up to as many projects, as many features you have. And in configuration phase, it parses down the script from those build.gradle file dependencies of each project that were added, and determines the task and their order in terms of by creating a direct acyclic graph. And finally, in the execution phase, it will execute a particular task graph for a requested command. This is important to understand in case builds take a very long time and you want to put debug logs to troubleshoot, or there is some third-party plugin or library you have added, and it blew out your build time. So this is great to look into those kind of issues and troubleshoot. Next, let's look at how Gradle and Android work together. Studio has dedicated the entire process of building Android apps to Gradle. Let's look at three Gradle concepts that we just saw into like live with Android. So with that, also we'll start putting something in the real. So let's look into it. I think I will also have to share my another screen because I want to start with the Android Studio. Stop sharing. Start another screen share. So I've just created a base template, nothing much, just it's a Gradle 101 file kind of thing. Like just named, like just created a brand new fresh project we all know about. Um, and if you look at the, like the structure, let's look at the structure. I know it sounds lame because it's trivial, but if you look at each and every directory in this root, you will be surprised how much Gradle does under the hood. So this first directory is .gradle directory. All the project specific cache goes here, including the version specific. So let's say right now, I just updated my Android Gradle and plugin and everything, so it's 7.3. But if I had worked on for this project on any previous Gradles, it will show up in the cache. Uh, the another is this app. This idea folder is just related to the IDE, so I'm not getting into it. Another thing is this app module or app directory. It's called a sub project by Gradle, having its own build.gradle. And it has its own build.gradle. So just note of that. Then there is a Gradle directory itself, which has a jar file and a properties file. Then I've just added a separate project. And then on the root, you will see this build.gradle file, um, which is the main script file. Like initially when you create a project, this automatically comes in, but this is where you will be actually, seeing all the magic happening. Then
May,
there's
sorry to interrupt. Do you think that you can increase the size of the screen?
Oh, okay. Let me see. Can you?
Yeah, this is much better. Thank you.
Okay, awesome. Thank you. Thank you for checking. And then it is Gradle.properties, and some script files. So this is which is a script, Gradle script, and Gradle batch file, which is for Windows and for Windows OS. And this is settings.gradle file, which is like the entry point to the Gradle projects. Um, so I think I am okay. Let me again. So yeah. So with that, okay, interestingly, like Gradle automatically cleans the project specific cache directory after building the project. If you haven't updated or worked on Gradle for 24 hours, it will check, and they will be deleted after 7 days, which was interesting to know. And you can also delete, like sometimes your cache gets dirty, you can just delete those folder, and Gradle will, Android Studio will regenerate them for you. Um, and then let's look at the Gradle properties, right? So let me again the screen, stop sharing, share screen. It's a So here you can see that there is a jar file in the Gradle folder.
Sorry, we don't see a screen.
Oh, you cannot see the screen? Okay. Oh, sorry, I got used to presenter. Yes. You can see now, right?
Yes.
Yeah. So this is like Gradle properties. This is the Gradle folder or package, and you will see there is a jar file and Gradle wrapper properties. Notice that it has also distribution base, URL, distribution URL, uh, uh, distribution path, zip store path, and zip store base. All this has a meaning in which, like, the Gradle will know where to install itself. So it installs at two places. One is in your project folder, root of your project, and the second is also Gradle home. The second also, like, it will know which version of Gradle it needs to download. So this is important. And usually in general, the properties file is nothing but it stores key value pair, and Gradle knows how to parse it. So again, like if you are ever curious, you can also compare, like go to Android Studio, turn on your preferences and check Gradle, and you will see that there is one-to-one correlation between what came part of your properties file along with what preferences it matches. It tells that, um, like the Gradle home path is defined here and it matches with your file, or you can always check where your Gradle home is over here. So I have now the absolute path of my Gradle home, and then the property files, right? So it tells that it please download Gradle from the properties file that is using the latest version. Um, and then let's look at the shell script. It is a lightweight script. It is executed when you run any Gradle command for the first time using Gradle loop. In a terminal or IDE's build or run menu options, Gradle's trick here is it knows how to install itself. Using this shell script, it will unzip the Gradle wrapper archive or a jar file that you see, and we will see them in the Gradle directory. So the question here, let's say you already have Gradle installed. Does it download every time the command is run? No. The way Gradle wrapper works is you call it with a Gradle command and it will check if the Gradle is installed. If it is, it will just pass along a command, and if it isn't, it will download the Gradle then. Next, see how you can check the version. Okay, this particular screen shows like how it's downloading itself and where this path is being stored. And the main advantage is that all developers have the same build environment. And if you want to check your Gradle version, if you just type in Gradle version, it will tell you all the details about where the file is located, what is the version, what version of Kotlin, Groovy, and JVM OS we have, everything. Which Gradle internally needs all this information to make your build. So yeah, along with just Gradle version, it will also have the information. And also like have you also ever wondered like how to know like which task to run at what time? uh, I know like when I started my Android development, it was funny enough that I would look at list of commands, and whatever I would know, I'll write them down and try to like memorize them. Instead of knowing everything comes handy out of the box, I really don't need to do it. Just run Gradle tasks or Gradle tasks all, and it will highlight all the tasks that you can possibly run along with the description and along with the group. So like for example, those Android tasks, you can also run like build task or life, they are related to the life cycle, like assemble Android test, app build, dependencies, build setup task which initializes the Gradle itself, and all different tasks possible. Um, let's see how the Gradle home directory. Also, you can look at all the tasks from the Gradle home. So this is a place in your IDE. If you go there, and it automatically show you all the different tasks possible. They are important because sometimes you don't. Sometimes you're in switching branches. Somebody updated a dependency, and your build is no longer compiling. Then it's definitely you need to like clean the cache and then start again. So these are for the command lines, and use them in the command line, and they will clean the cache for you and stuff like that. So highly recommend if you ever want to like play around with these commands. uh, Also, like I would say the Gradle home directory very important to understand because this is the place where it stores the global configuration, properties, and initialization scripts, as well as caches and log files. So if you look at the structure, the caches directory, it is a global cache directory for everything that's not project specific, because project specific goes into the root of the project Gradle file, Gradle package. It also has version specific caches to support incremental builds. Um, Also, there are two more directories under, which is modules and jar. They are used for sharing caches, for example, for artifacts of dependencies. The daemon package, which logs all, like all the stuff related to Gradle daemon. Gradle always have daemon running and caches some of the outputs. And finally, the wrapper slash disk. If you recall, this is exactly where we said we will be installing or unzipping our Gradle, right? The Gradle archive. And then the most important is also the Gradle.properties. It is a global Gradle configuration properties. So Gradle automatically again cleans this directory as well, from the cache perspective, and the cleanup runs in the background when Gradle daemon is stopped or shuts down. So just to like summarize what we saw is in theory, how it looks in the actual picture. This is you will see, how the folder structure in the real Gradle home looks like. And then we'll also look into like all the, and interestingly, it will also, so if you open the libs directory, you will see the many different archives um, being downloaded by the Gradle and cached. So when you run the build, it's damn fast. Um, and next, so I think we noticed right now that there are two main directories to perform and manage its work. One is the Gradle user home directory, and other is the project root directory over here. Also notice that both have Gradle.properties file. So have you ever wondered why there are too many Gradle.properties file? And also, have you ever run into an issue where you expect some particular output to happen in a way but ended up not happening? For example, we work on so many features and you want to turn off a particular feature. You have added that property as in gradle.properties file, but when you run a build, you will assume that the flag is off, but it's not taking into effect. It could be because um, oops, sorry, what happened? um,
We can see a screen. Oh,
okay.
yeah, no.
Yeah. I think it was, I think I must have some deep link and it was going to my link. So, okay. Just to name like what kind of different properties you have, this is just like summarizing some of the properties like um, Gradle.caching. It is all related to the caching, whether you want to have your outputs being stored in cache or not, whether you want to configure on demand an optimization flag. If you turn it on, it will try to only execute those tasks which are necessary for that particular command. Whether the daemon is you turn it on by default, Gradle always run a daemon. It's a long-lived process, so not only are we able to avoid cost of JVM startup for every build, but we are also able to cache information about the project structure, files, tasks, and more in memory to speed up the builds. And then there is JVM arguments. It's very important because this is where you also provide some memory settings to the Gradle itself. So if your builds are slow, also check, what kind of JVM settings do you have. These properties can be set by either of the Gradle properties, and that is not all. There are many ways you can set up these properties. The first one is like command line. So whenever like you run a Gradle command, you can pass on some properties flag using -p, and as in the snippet on the code in the right. Again, you can also pass on some system properties using the command -d through the command line. And there are environment variables you can set. And as we talked about, the Gradle dot in Gradle home and project root directory. But the priority is it always takes the command line first and then overrides any other properties being set. So priority of different properties being configured from lowest to highest. So the highest is the command line. And let's look at how Gradle interprets Android project configure task graph. So Gradle is going to read the settings file first and configures the project name. In our case, Gradle 101, when I was preparing this demo, it was a different project. And then it will read how many include statements and it has. Um, so rarely Android projects are that this simple, which will only have one include statement, right? It's always more complex, having many different library projects or feature modules all being part of one Android project. So if you look at it, let's add few more modules in Android Studio. These are just dummy projects. We just added some modules here. And you will notice that even the settings file, it added more include statement by itself. Uh, Interesting concept. Gradle calls it a project, and Android Studio refers to as a module. So the terms are quite interchangeably, so don't get confused. And typically in our app, we have thousands of modules, and each one of the module is considered a project from the Gradle's perspective. Finally, let's see how the Gradle processes the settings.gradle file. Settings.gradle determines how many projects are added to the build. There are as many projects as many build.gradle files. Each one of them include statement in the Gradle file is going to result in a project instance. Finally forms a project hierarchy. So that is important, and this that completes the settings. That completes the initialization phase, and we'll see how the configuration looks like. Initialization was quite straightforward. The most challenging part is the configuration. Gradle will look into all the build.gradle files for each project, and let's see what happens under the hood. Mm, So each project passes through a configuration phase. The project instances defined by the Gradle in initialization phase are then broken down. Every build script, not just that, all the dependencies of the project or any plugins and their dependencies are also resolved. And then tasks are ordered, entire task graph is generated because Gradle does not know in what order the tasks will be executed. Even if you had run Gradle help, it would execute and evaluate every single task. Like the Java plugin example we saw earlier, let's say Android project has a dependency on Java plugin, and Java plugin and its dependencies are evaluated then. The task graph will emerge like in the screen. Once the configuration phase is completed, it will know which command or which task it will execute, and it will only run that part of the graph. So before running into the execution phase, let's take a stab at top level build.gradle file. This script, which is specific to like Gradle. So in the configuration phase, we were talking about build.gradle files, and eventually all build.gradle files from different projects get flattened at the top. So what actually the top level build.gradle file consists of? A build script where you configure repositories and dependencies specific to a module. You can configure repositories and add dependencies that are common to all modules and required to build Android project. So now let's look at the repositories block. The repositories block configures the repositories Gradle uses to search or download the dependencies. Gradle prefigures support for remote repositories such as JCenter, Maven, Central, and Ivy. You can also use local repositories or define your own repositories. The code below defines JCenter and Google as a repository. Gradle should look for its dependencies. The next is dependencies block. The dependencies block configures the dependencies Gradle needs to use to build the projects. The following line adds like Android Gradle plugin, Kotlin plugin for Gradle. First, we declare a dependency on, like Gradle on Android, and this is actually a Maven artifact coordinate. And the way Maven coordinates are written using a colon as a delimiter. So it's like group ID, colon artifact ID, colon packaging and versioning. This is where Android Gradle plugin for Gradle lives. And finally, let's look at the all project closure. All block is where you configure the repositories dependencies used by all modules in your project, such as third-party plugins or libraries. All project block adds JCenter so that every sub-project will depend on it. However, you should configure module-specific dependencies in each module level. So now let's look at external dependencies that we were talking about. There are three kind of external dependencies. The one is a module dependency, which is like an application module can include in its build file a list of other modules it depends on. When you build this module, the build system assembles and includes the required modules. Then there is a local binary dependencies. It means like you have your own artifact which is not not hosted anywhere on the server, and you want to add that as a dependency. So all you need to do is provide the path, the file tree path. It calls compile file tree, and then it will be able to include that in a compilation class path and in the final package. And finally, it's a remote dependency, Maven or Ivy or any kind of such. The visualization always helps. Here you can see like Gradle build accesses local and remote artifacts and caches them locally by downloading them via Maven, Ivy, or any other host. Ooh, where we are. I think we were at the build phase, and now we can discuss the final phase of the build called execution. So by the time it reaches to the execution phase, it looks at the requested command and then generated an output based on that. So continuing from the same Java plugin example we saw in the previous slide, let's say you want to run an assemble task. Gradle in execution phase will traverse down the task path from assemble, from assemble at the root and going all the way to the leaf node, and then execute through each task in reverse order, going from the leaf node task all the way up. Once all the tasks complete executing, you will have generated output. And there are also many callbacks that you can hook into if you're interested to debug on the project lifecycle. But if I have to recap the entire build phase in one slide, let me show you it is possible. Like, let's say your Gradle build started, and in the initialization phase, you can see that the settings are evaluated, the project instances are created, which completes or marks initialization phase done. Then it's handed over to the configuration phase where your all the project starts getting evaluated, and the task graph is ready. Once it's ready, it notifies that I have the task graph, and the tasks start executing based on the command you type in. If you're still with me, let's do quick demo snippets. Uh, as always, we always start with a hello, like hello world Android project. So let's do a hello task. So let me just stop my screen and start, like share another Android Studio. Okay. Mm, just to, like, I know I might run over time, so I have added some of, so go to the build.gradle file, and here this one, and let's say it's so like, let's say I have a task, this, like the Gradle file, the Gradle project has a handle to the project, and because of the project, you have handle to all the tasks. So if you want, you can get all the task, get task by name, and just a simple task. And here you are saying like, I want to register a task, and you can also say define, like what do you call it, like hello world, whatever, and then just like you can say it needs some kind of handle to execute. It needs an action, so you can say do last or anything, and you can just print something like that. And all you do is just go to Gradle, type in the command hello world, and it will execute. So you can see that it has done. Again, you can also add a group. So if you add a group, it will, when you list out all the tasks, let's say my custom tasks, and it's um, it's a string, it takes a string. And if I go and run Gradle view tasks, you will see that it will group and list even my custom tasks over here. Which is like, I found it very interesting because now I know how to manipulate the Gradle files um, beyond my comfort zone. And also there are some more APIs that I want to talk about, like dependent tasks, right? So what is a dependent? So let's take an example where you want to shoes, but you don't want to put on shoes without putting on socks, right? So the shoes task depend on the socks. To do is add depends on the block. And if you now run put on shoes task, it will actually show you that it will first execute socks, and then it will execute shoes. This things like, this is how we made the connection, right? When we did the Java plugin, one task dependent on each on other. So it will delegate to the other task to get that task done, and then once that task has executed, it will then run its own task like that. Also, you can create custom tasks itself. For example, you can use default task, and you can see that it takes an action. You can define an action, and let you define greet. And if I now run and you register that task using the task type. So here, let's I just want to run hello. It will execute, and it will show this like all the tasks are right. Interestingly, you can also do a plugin. So this is a plugin, and if you look at it, it has an interface, and it is applied. So plugin is applied to the project, right? So you can write your own custom plugin, and then the every plugin has a task. So you can in the apply block, you can add a task. So if I want to say I want to run hello plugin task, I just need to run it, and it will execute the task for me. So these are like some of very simple concepts, but they are very powerful. Also, I wanted to show the callbacks that we just saw for the life cycle. Them on. It's like you add a build listener. This is nothing but a listener which you can add. It's called a build listener, and it has four methods: before settings, settings evaluated, projects loaded, projects evaluated, and build finished. This is exactly what the life cycle of the Gradle consists of. So you can have a hook into the build. Um, and now if you run any command, let's say I want to run version, it will still like like the version is too simple, I think. Let's say I want to do help. Yeah, it started logging all the different stages of my Gradle life cycle. My settings assessment has completed, loading completed. After initialization, you can access the root project. This were my logs. All projects have been evaluated, and then the task is ran. Um, what else? Now I let me share again the screen. I want to go back to Android Studio and go to the next topic, which is Android Gradle plugin. Very briefly, um, let me share my screen. Stop share. Okay, so we saw the demo. I will share my slides once they are done, so you can always refer them back. Um, but I just added the slides in case like we didn't have time to go over.
So do a second part of this.
Yes, yes,
Sure.
yes. So I'm doing that. So now we know that Android Gradle plugin is not Gradle. AGP was created to generate domain-specific language specific to Android. You add your dependency on Gradle plugin to Gradle, and Gradle will then expose the Android-specific APIs that can be further configured. Ever wondered how complex the task graph for Android projects is? It is super complex. I could not even fit into the slide. But just to like have a brief overview, there's a simplified task as well. I just took it as a simplified task, and you can see that the entire task of building Android application is being orchestrated using Android Gradle plugin. Blue boxes are the inputs to the task, and it becomes the next task, and the task are defined in green color. So the build process involves many tools and processes that generate intermediate files on the way. And like Android asset packaging is where it compiles all your resource files, manifest, merges them together, and like an ordered Java is produced here. Um, AIDL also tool converts your AIDL interfaces into Java interfaces, and all of your Java code is then compiled using the Java compiler. Um, it then goes into the text tooling, from text tooling, all the different compile sources like your resources, images, and everything gets packaged into a package builder. Um, and finally, an APK is created. Depending upon your build variant or build type, it will generate whether it's a signed file or not signed file. Um, Another hook that I want to like really say is like look at the plugin source file. There is a plugin reference. This is really awesome, and you will see like most of the properties that we set for Android, they come from app extension. It is nothing but a plain Pojo in a way, but Gradle defines any extension as like the models. Um, and with that, stay tuned. Like, what are the advantages? Immediate advantages of doing this, the Gradle and the build system is you will know how to have like better and faster builds, and you can always improvise if something goes wrong. Also, it gives deeper understanding of the transitive dependencies, multi-module projects, and multi-platform projects. You can write your own custom plugins to solve your needs. Also, the peer programming become easier because now you have the same environment, you know exactly what to look for. And you can also work on older projects because all it needs is different build tools, right? So you can understand that part and get your projects working. Stay tuned. I'm still, trying. I think I could only cover some part of what I really wanted to add more. So I want to break it down into further series, and this is what I'm planning. If you guys have specific things, please share with me, and I'll try to like have a presentation on it. Some of the talks that I want to highlight is this is from my colleague Inaki. He gave a talk about scaling Android builds in pandemic times, AndroidCon last year. It's a great talk about configuration cache, visualization tools, performances. Another I really liked is from 2018 talk. It's called Deeper Dive into Android Gradle plugin. It actually does a lot of debugging as well. So it has like some snippets where you can actually hook into the code and debug it, like a breakpoint, like how you can make that happen using your IDE. Third talk was the latest from like the DevFest this year, and they talk about the latest changes Android Gradle plugin APIs have made. So with that note, I just want to say we are hiring at Tinder. If you're interested, please connect with me, or know. And thank you, Deepa, for organizing. And thank you so much for having me.
Wow. Thank you, Meha, for I'm really I'm awed because let me turn on something here. So I'm not an Android developer, but I know that it takes too much of time. I tried Android before, but then it usually tries to, when you try to build, it was back in the days I tried, it used to take a lot of time. I was like, okay, when this thing will get done, So that was my first take, but then I moved away from Android for sure. But it was really an interesting topic, and I'm pretty sure that this could be made as a series. So let me know if you want to do a series of talk, or we can have workshop kind of a thing, so that we could do
Hmm.
it ahead of time too. So
Yeah.
um, I would want the audience to post questions if you have any, and please do let us know how we are doing and what are the topics that you want to hear from this chapter. I'll try to find out, and if you're interested in talking, please reach out to me as well. Um, and with that said, we are almost about time. So please post your questions if you have any. And I also put Meha's LinkedIn there. You could connect with her. And yeah, let's go from there. We have 3 minutes to go. Okay. So if you have any questions, please post it now.
Yeah. I try to keep it basic, but then, yes, like
Yes,
most important is that please have some takeaways from the presentation.
yeah, the thing is, like I said, I'm not an Android developer, but I do understood, like when you showed me the visuals of it, the code demo, it was really, really helpful.
Yeah.
This is
Thank
also
you.
recorded. It'll be posted in the YouTube channel. I already posted the link up there. So please subscribe for GDG San Jose chapter. And we can also do, please, you would get a feedback from us. Let us know how we are doing and what are the topics that you want to hear from this chapter. And then we'll try to find out. I'll try to find out how I can fit it in. And Meha, great job. Thank you so much for coming here. And it was a pleasure having you. And
Thank
for people
you.
who are
Pleasure's
here,
mine.
please do connect with us for yet another event, which is going to be happening on the 20th um, with IoT and mobile apps. So she's going to show something with React. And yeah, it's going to be a fun topic too. I don't want to give it away, but please do join us.
Thank you, Deepa. I know it's such a hard work, organizing is not easy at all.
reach
And
out
you're doing
reach out to
awesome.
me if you guys want to talk as well. I'm here, and you can also connect with me. I'm connected to Mega. You can find my LinkedIn as well in the GDG community website. Thank you guys, and if I don't see you again, happy New Year and happy holidays.
Same to you. Happy New Year. Happy holidays.
Sure. Thank you so much, Meha, again.
Thank
um,
you.
yeah. Bye.
Bye. Thank you for having me. Bye.
Pleasure. Thank you.